this is Himabindu from the Department of CSIT. So today in this video, I would like to explain or discuss about the problem solving on deterministic finite automata with divisible pi. So here we are having the examples of DFA, like how to the string starting with and ending with, and how we will combine the starting and ending. So we already discussed about the designing of DFA. So now in this video, I would like to explain about the problem solving on designing the DFA with divisible pi. So we'll get into the example. So before going to the examples, let me explain about the brief introduction about the deterministic finite automata. So deterministic finite automata, which is having the phi tuple. So here the phi tuple represents the Q. So Q is nothing but a finite set of states, and the sigma, which represents the input symbol. So whatever the string formation, the string is formed with the input symbol. So those are all like capital and small letters or as binary numbers. Those are the examples. And the starting state, which is the start, to construct a DFA, we need to give one initial state. So that is represented as a starting state. We will generally denote this starting state with the Q naught. And F is the finite state. So here the finite set of states, based on the transition diagram, we have multiple final states. So here the F is nothing but finite set of states. And delta is nothing but it is a transition function. So transition function which represents the for giving one input symbol from which state to it is going to another state, and based on the input symbol the transition, so from which state, from the initial state to intermediate states or intermediates to final states, so that represents in the delta. So that is named as a transition function. And here coming to the DFA transition function, so here we have a Q cross sigma, so that represents the Q is nothing but a finite set of states, so those are named as a capital letters. So if we take one example of here, if Q is nothing but there are many number of, based on the transition, there are many number of states are required. So those states are in the capital, those states are we are giving as a Q, and it is Q cross sigma. So sigma which represents the input symbol. So I will take example of input symbol 0, 1. So here these are the combinations. So here the transition function delta which represent Q cross sigma. So for every state we need to give input symbol. So what is the result? We will get that which state it is going to this in the transition is called transition function. Suppose here if you take example of Q naught, so Q naught is a Q and we have to give 0, 0 or 1. So if you give 0, it is reaching to the another state. So that represents the transition delta of Q naught, 0, which leads to the Q1 state. So this is about the transition function that is represented as a delta. And here if we have many input symbols, so here one more symbol is also there, one is there. So if we give 1 as an input here, it will reach the state itself. So that represents the delta of Q naught, 1 leads to the Q naught. So this is how we are writing the transition function. So and here this DFA is defined by the phi tuple notation. So those are named as a Q, so which is a finite set of states, and sigma which is the input symbols to design a DFA, and Q naught is the initial state. So generally we will write the Q naught as an initial state, and here this arrow mark represents it is an initial state. Sometimes it is also initial state is also a final state based on the transition. So based on the examples what we are taking, based on the languages we are taking, so this initial state may be a chance of final state also. And the final F is a finite set of states. Suppose here 2 or 3 final states are there. So here this two are the finite set of states, so named as a F. And delta is a transition function, so delta which is having q cross sigma is equal, which leads to the q, which state it is going. So this is about the brief introduction about the DFA. How to design a DFA, we need this 5-tuple notation. So we'll take one example, and with the step by step we will discuss how to design a DFA. And here they build a DFA for the following language. So here the language which is having the string substring 01. So the substring 01. The string they are saying that string 01. So 01 is nothing but by seeing this one we can represent it as a sigma is equal to 0, 1. So the string substring, the whatever the word we are taking in that one, there is a 01 substring should be there. So this is the condition what they are telling. For this is the language, we can say that the substring, the language which contain the 01 as a substring. So by seeing this one, we can say that there is no limitations of initial and final state. So initial end of the starting of the string and ending of the string. They just mentioned that 01 is a substring. So by this logic we can write, initially I can write either 0 or 1 and along with the 01 substring, and one more case, starting is the substring and ending either 0 or 1. So this is, and there is one more case. So 0 or 1 starting and 01 is a substring and 0 or 1. So either the string which starts with either 0 or 1 or the string which starts with ends with 0 or 1 and the both starting and ending either whatever it is, we can have the substring only 0, 1. So for this language, how to construct a DFA, we'll see. So to design a DFA, we need some steps. So first one, we need to identify the sigma, that is nothing but input symbols, and decide on the states. So here, minimal states are required here. So how we will find the number of states, that is nothing but based on the language conditions. So here the substring 01. So 01 which is a length of 2. So 01 is a length of 2, and for this one we require 2 plus 1 states are required here. So how? Because initially we will take one state and in between there is a transition of 2 length 0, 1 and it is reaching the final state. So this is initial state and it is reaching the final state. So this is the minimum length. So for minimum length, the number of states are required is 3. So minimum length plus 1. So that is represented as a number of states here. So here and we have 0, 1. And there is one more condition. This may be in the language. This is also having the this 0 or 1 is also a part of language. So that how we will write 0 or 1. So if we already have 0, and if we have 0, so here if we have repeated 0, we will write it as a like this. And if we have 1, so we will write it as a 1. And here to design a DFA, we need there is a 0, 0 here. For single input, it is not reaching the multiple states. So that is the condition we need to follow. So here how to construct a DFA, we'll see. So this is not happen here. So if we write this 0 in this diagram, it is as a NFA. So DFA construction, we have only for single input, we need to reach the single output, single state only. And design a start state and final state. So here we need to find the initial state and final state like this. So this is the initial state and final state. And decide on the transition. So here we need to decide on which state it is going to the we will get one input, and for the one single state we will give 0 input or 1 input. Where it is going, we need to find the transition. So the final states are accepting states and the other states are non-accepting states. So we will design a DFA for this example. So first we need to start with the Q naught, and minimum length is 0, 1. So we are reaching and once 0, 1 is reached, we need to find, we are in the final state. So that is represented as a accepting state. Double circle represent the, so this one is the initial state and this one is the final state. And here, so 1, so we just saw that initially if the string is starting with either 0 or 1, so 0 already there and we need to find 1. So if we give 1, it should be in the self loop. And also for this last also, why? Because so 0, 1 we are representing. So 0, 1, so either it ends with 0 or 1. So here if you observe, we are giving only 0 to 1 state only. And here we are not giving any 0 here. Why? Because it is not a NFA. And here one more 0. So 0, for the construction of DFA, we need to find the paths for every input symbol. So if you observe, here 1 is there and 0 is there. So only we have the sigma value is equal to 0, 1 only. And here, and if we have earlier, so earlier only 1 is there. What about 0? If we give 0 in the middle of this 0, 1, if we got a 0, so where it is going? So where it is going in the sense, in the self loop only. And so that we can also satisfy this 0, 1 substring, and 0, 1 substring is also satisfied along with the initial and final state. So initial condition and final condition we are satisfying. And so this is how we are designing the 5 tuple notation. So, and for this diagram we constructed a transition table. So here the transition table, so which are rows and columns we have based on the input symbols where it is going. From Q naught state, it is going to, whenever we give 0 as an input symbol, so it is reaching the Q1 state. So for Q naught, when giving 1 as an input symbol, it is reaching the self loop. So that is named as Q naught. Like that, by seeing this transition diagram, we can also construct a transition table. And with this is the starting example. So we have, with this we got a basic idea of how to design a DFA. And we will move to the divisible by examples. So the DFA which is constructed for the string which are divisible by numbers. So here the construction of DFA which accepts the set of all the strings over 0, 1. So set of all the strings which are in the 0, 1. So we can directly say that the sigma is nothing but 0 or 0, 1, which can interrupted by the binary number which is divisible by 2. So here the binary number. So we already know that a binary number which is having the input symbol 0 or 1. So here the binary numbers. So binary numbers which are divisible by 2. So which are divisible by 2 in a sense. So if suppose we are taking the 4 as an numbered integer number, if we are dividing with the 2, so if you give 2 as an 2, it will give the remainder 0. And like that, if you take another binary number, another integer, so with the 5, if you give, it will get 1 as a remainder. So like that, whatever the number we are taking, it is divisible by 2, and the remainder is either 0 or 1. So these are the two states. So that by seeing this one, we have the two states are required for the divisible by 2. So the binary number. So binary number, let me discuss first integers. So integers, whatever the number we are taking, for that one we have the two reminders when it is divisible by 2. So those remainder we can named as a or not R1. So R naught represents 0 remainder and 1 represent 1 represent 1 reminder, R1 represent 1 reminder. So and here we'll take integer values first. So first integer is 0 we'll get, and here 1. If you write 1 divided by 2, 2 divided by 1, we'll get 1 reminder. And here if you take 2, it will get 0 as a reminder. And here 3, if you will get 3, so 2 by 3, which is having the reminder 1. So which leads to the 3 is divisible, 2 is divisible by 3, will get 1. And like that we need to write all the numbers. So 5, and here 6 and 7. So we will get the two reminders here. So for this one we need to construct and we just now discussed about the integer values, and here this integer value we will convert, we will represent this in a binary number. So here we have a 2 reminders, so that we have the states Q0 and Q1 we will take, and here 2 states are required, so here we need to write the numbers. So here 0, so we'll represent this 0, 0, 0 and 0, 1, and this number represented 2 represented in 1, 0, and 3 represent 1, 1, and 4 represent 1, 0, 0, and here 5 represent 1, 0, 1, and here 6 how to represent 1, 1, 0, and 7 1, 1, triple 1. So like that we need to write all the numbers in a binary form. So here when we are giving 0 as an input, so it is reaching the self loop. So for the 0 input, so it is the initial. So 0 state, 0 reminder, you will get, we will go for the same state only. And here 0, 1. So we already have 0, and if we have a 1, it is reaching the Q1 state. So this is 0, 1. And here 1, 0 is there. And here 1 is there, 1, 0. So if we have 1, and here already there 1, and if we got 0, it is reaching the same state, so it is reaching it is in the reminder 0. So 1, 0 is acceptable, and here 1, 1. So already 1 is there, and if we give one more 1, it is in the Q1 state, that is represent, it is a reminder 1. And here we did just now decide 1, 0, 0. So 1, 0, 0 is there, already there, no need to design, and 1, 0, 1, 1, 0, 1. So this is also satisfying. And here 1, 1, 0. So 1, 1, 0. It is reaching the Q0, that is nothing but a reminder 0. And triple 1. So 1, 1, 1. So this is reaching the same Q1, that is represented as a reminder 1. Reminder 1. So this is how we are designed the number, binary number, which is divisible by 2. So first we need to find out how many reminders we will get, and first initially we need to find the integer numbers, and then we will convert those numbers into a binary numbers. And here we need to find all the transitions from which state to which state for the given input. So this is about the number which is binary number which is divisible by 2. And one more example. So we will take binary number which is divisible by 3. So here same. So 3 which is divisible by, from 4 onwards I will take. So 3. So 3 ones are 3. So we will get 0 reminder, and 3, 4, if we take 4, 3, 1, 3, and we will get the 1 reminder. And here one more reminder, if you take 5 number, and here if 3 ones are 3 and 3, we will get the 2 reminder, and one more number we will take, and if we take 6, and we will get 0 reminder. And if you take 3, 7, we will get 1 reminder. So this is continuous. If you divide n number of integers with the divisible by 3, we will get the reminders 0, 1, 2. So we have to write the reminders like R0, R1 and R2. So this represents the reminders. So 0 reminder, 1 reminder and 2 reminder. And second step, what we have to do, we need to find the integers which are divisible by 3. So if we get 0 reminder, what are the values? So 0 initially we will take, and 1, 2, and next 3, 4, 5, 6, 7, 8, 9, 10, 11. So like that we can write n number of values for the divisible by 3. So we will get the 3 reminders. So for this we need to have the three states. So what are those states? We will write. So here Q0 as an initial state, which is a 0 reminder, and also it is a final state. Why? Because if we give 0 as an input, it is in the same state, initial state only. And Q1, which is a 1 reminder, and Q2, which is 2 reminder. And for this one, we need to write the integer values in the binary number. So 0, we will write 0, 0, and 1, we will write 0, 1, and 2, 1, 0, and 3, how to represent the 3? So 1, 1, and 4 represent 1, 0, 0, and 5 represent 1, 0, 1, and 6 represent, so 6, 1, 1, 0, and 7, 1, 1, and 8, if you take 8, 1, 0, 0, 0, 0. So these are all the binary numbers representation, and for this one we will find out. So 0, 0. So if you get 0, 0, we need to be in the same state. So Q0 state only. And Q1. So Q1 Q1 is 1, 0, 1 is there. So 1, 0 is there, and if you give 1 as an input, it is reaching the Q1. So that is, we will get the reminder 1. And 1, 0 is there, and here we need to write 1, 0. So if it is giving 0, we will reach the Q2 state. And we'll take 1, 1. So already 1 is there, and if you give 1 as an input symbol, it has to reach the Q0. Why? Because we have to go for the, if you get 1, 1, it reaches the Q0 state only. And here 1, 1, 0, 0. So 1, 0, 0 is there. And here, if you give 0 here, it has to reach the Q1. Why? Because it is in the reminder 1. And 1, 0, 1. So 1, 0, 1. So if you give 1 as a reminder here, 1 as an input here, it has to reach the Q2 only. And this finished. And here 1, 1, 0. So 1 is there, and 1 is there, and 0. So it's already satisfying. And here 1, 1. So it's reached to the needs. It reached the Q1 from Q0. So 1 it is reaching Q1, and 1 it is reaching Q1, and again 1 it is reaching the Q1. So this is also satisfying. And 1, 0, 0. So 1, 0, 0, and again 0 will reach the Q2. So this is how we constructed a DFA, deterministic finite automata, the binary number which is divisible by 3. So like that, here we constructed divisible by 2 and divisible by 3. And in the next example, so number of A's divisible by 3 and number of B's divisible by 2. So here we just now individually discussed about the divisible by some numbers. So if the string which is having the A comma B as a input symbol, and for this A, it is for one input, it is having the condition which is the number divisible by 3, and B which is having the condition B number divisible by 2. Let me write A which is having the reminders R0, R1, R2. So why? Because which is number divisible by 3. And for B, we have two reminders. One is R0 and R1. So here we have to combine these two. So the string which is having there may be A, which is A's number of divisible by A's is divisible by 3 and B is divisible by 2. So that we need to find the states. So here how to find the states in the sense. So here let me write the state A, B, C, D, E, F. So here we need 6 states here. So how to write these 6 states in the sense? A's number of A's which are divisible by or not, number of A's or not, which is having the or not, and a reminder. We have to find the remainder which are divisible. Remainder 0 we will get for the A's. And here we need to find there is a combination of these two, so that B's, number of B's which is having the or not. And for these B's cases we have only two options, one is or not and R1. So we will get a number of B's which are divisible by 2, we will get only either 0 or 1 remainder. So for that one is, so R1 we have to write all the possibilities. We first written R0 and we need to write the R1, and B's we need to write like same R0, 0 remainder. And these are all the probabilities for the construction of this string. So here A's, so remainder which is having R2, and B's which is R0 only, and A's. So here we written all B's which are remainder having 0, and we'll write remainder 0. And for the B's, so we'll write again A's R1, A's R2, and in second case we need to find B's with R1 and B's with R1 and B's with R1. So remainder 1. So these are the 6 cases what we have written. So that we need to find by seeing this one, there are 6 states are required. So every state, from which state to which state it is going for the input symbols, we will write in the transition table. So let me draw the transition table, and here what are the input symbols we have? A comma B. And here transition function, and how many states are there here? A, so this is the initial state and final state, and B, C, D, E, F. And here if you give for the A state, if you already the state A represent, it is having the remainder 0, number of A's is 0 and B's is 0. So if you add one more A to this state, so which is leads to the B. So that means the here remainder 1 represents additionally A1 is having. So that 0 is 0, which is 0 with the plus 1 will get 1 only. So that 1 remainder is the A0. A's with the remainder 1. So and so that combination. So B is not changed. Why? Because B is the same thing. So that B is not changed. We are taking only input A. And whenever we additionally add this state with A, it is reaching the B state. So that what we represented here. For the B state, if already one remainder is there, if you add one more A to this one, it is reaching the C state. And this is only A input symbol. We are not talking about a B symbol, B input symbol. And here from C state, so if you add if you add one more A, so it is divisible by 3. So that 2 plus 1 will get 3. So which is divisible by 3. So it is reaching the A state. and that is number of A's is 0. So A's is 3, so 3 which is divisible by 3. So we'll get which is the number which is divisible by 3, we'll get a 0 remainder. So that represents A's with the remainder 0. And D, so D is a 0, 0, 1. So 0, if you have A as an input symbol, so it is reaching the state. So from the D state, if you have one more A, so it is reaching the E state. So why? Because, so we need to check here. It is not going to B. Why? Because B is R1 here. So we need to check here B1 also. So B1 which is E represented. So D, when we give A, additionally A to the D, we will get in the state E. And for the E state, same, it is reaching the F. And if you give F as an F, so 2 plus 1, additionally if you give one input symbol, it is reaching the state D. So for the A input, we return the transition function and where it is reaching. And if you take B as an input symbol, so B as an input symbol, so B is already 0 is there. And if you additionally add B, one more B to this one, so it is reaching the D. So why? Because, so 0 plus 1, it leads to the B number of B's, one more B R1. So number of B's with the R1 with the same R0 is not, A's with the R0 is not changed. So that's why. And for the B, so R1 is there and we need not to change this R1. And if you give 0, if you take this 0 and if you add one more B to this one, it is reaching the R1. So that what is the R1 here? E. And this C with the, this is R1. So we need to continuously, we can write R1. So whatever the B is there, if you add one more, it will reach to the next 3 states only. And here, if you add one more B, it is divisible by 2. So that it is reaching the states here. So we'll directly writing A, B, C. So for this one, we can also construct a transition diagram. So A is the initial state and final state, and if you give A as an input symbol, so we'll get A as an input symbol, B, C, D, E, F. So if you give A as an input symbol, it is reaching B, and for the B input symbol, it is reaching D. And from the B state, if you give A as an input symbol, it is reaching C, and if you give B as an input symbol, it is reaching E. And from the C, if you give A as an input symbol, it is reaching A, and for the B input, it is reaching F. And from the D state, so D, if you reach the D, it is having the A input symbol, and from D, B, if you give B as an input symbol, it is reaching A. And from the E state, if you give A as an input symbol, it is reaching F, and for B input symbol, it is reaching B. And from the F, it is reaching the, if we have to give A input symbol, and from the F, we need to give here B input symbol. So this is how we are writing the transition table, and we can also construct a transition diagram. And this is about the number of A's divisible by 3 and number of B's divisible by 2. And one more example. So here the length of the word, the number of A's word mod 2 is equal to 0 and the number of B's mod 2 is equal to 0. So this, by seeing this one, which are divisible by all the numbers, so the number of A's which are divisible by 2 and the number of B's which are divisible by 2. So here number of divisible by 2 only, and in the sense we'll get all the A's which are having even numbers. So even numbers, and B's are also which are divisible by, so those are also even numbers. So we already discussed about the number of A's and B's, even numbers and odd numbers. So here by seeing this one, those A and B are even numbers. So for this one, language, so sigma and AA, BB, and just now we write an A even number or B even number, and there may be a combinations of both A and B. So either we can write AA, BB, or there is a combinations AB, AB, and BB, EAA. So all the possibilities of even number of length. So like that, for this one, how to construct a DFA, we already know that 4 states are required here. So A, B, C, D. So A represent even number of A's, plus even number of B's, and one B represents even number of A's, and odd number of B's, and one more case, odd number of A's plus or even number of B's, and odd number of A's plus odd number of B's. So these are the 4 states. So that for these 4 states we need to construct we need to construct a transition diagram. And here I am taking A, B, C, D. So same concept. Previously we discussed, when we add one more A to this one, it is additionally one more A, it is reaching the another state. So that here also, for even number of A's, even number of B's, that is 0 is also accepted. So why? Because even number 0 is the even number. So here if you give 0 as an input symbol, it is in the self loop. So here 0. So if we have, if 0, 0. So even number of A's and AA, it is reaching the self state only. And if you add one more, this represent even, and even odd, even, and odd. So here if you give 0 A as an input symbol, it is reaching the same state will be. And here also if you add one more A to this one, it is reaching the B state. And here if you add one more B to this one, it is reaching the D state. So that is number of A's, B is 1, and you will get one more B, it is reaching the B states, that represents A, B. So these are the A, B which are even number of A's, and here even number of A's and even number of B's. So here A. So odd number of A's and even number of B's. So here odd number of even number of A's and even number of odd number of B's. And here A, it is odd number, so that it is reaching the state. And here the B, so B, it is odd number, and A is also, so A, if you give A as an input symbol, it is a odd number. So A, B, both are odd numbers, so that it is in the odd number, which is a D state. And here C, so we already gave A input, and if you give B as an input symbol, it is reaching the A state. So here A state it is reaching, so that B is the even number. So how to give B is a even number? So here from this one we will get B, and one more we need to write A. So if you observe A, it is reaching the B states, that represents odd number of A's, and with the B is here, if you give B as an input symbol, so here if you give B as an input symbol, it is reaching the, so B, so it is even number. And here, and B, so if you give A as an B as an input symbol, it is reaching the A state. So B, so two B's are there, it is reaching the, two B's are there, it is reaching the even number of A's and even number of B's. And here A, so it is a even number of A's, and single B represent odd number of B's. So like that, we just constructed a n number of divisible by A is divisible by 2 and B is divisible by 2. So this is about the divisibility concept in the construction of DFA. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.